everybody, my name is Kelvin and today we're going to be covering another CCNA Security lab from the version 2 lab manual. This lab is, for those that have got the lab manual, is 2.6.1.2 and the title is Securing the Router for Administrative Access. So I'm doing this in GNS3. I'm not too sure if it can be done in Packet Tracer. However, for those that want to follow along, you know, by all means you can follow along using this same topology. I have added an additional cloud which routes out to the internet, and what I'm going to do there is I'm going to configure that so that we can connect the PCs to my real internet connection to you know, pull any files that we might actually need for this lab. So I've set up the topology, and what I'm going to do is I'm going to start right from the scratch and configure everything which is asked of me in the lab. So to begin with, we're going to configure basic device settings. So I'll start by first powering it on all these devices. Just for your information, the DC interfaces cannot be configured in this lab due to the images that I am using. However, for those that have actually got images that can work, or using Packet Tracer or some other software, you know, by all means configure the clock rates and the DC interfaces. So I'm going to start by powering on all these devices, and I'll make the syntax font slightly bigger so that everybody can see it and follow along. So I'll just console in. There we go, that's slightly bigger now. I'll just do the same for all the other ones as well. Just so that those follow along can actually see the syntax. Okay, so I'll start as well powering on these machines which are running a Windows 7 operating system on both of them. So they do take a short while to start, so as they fire up, what I'll do is I'll configure the routers. The switches are just acting as dumb devices, so no configuration is required on those. So what I'll do, I'll just minimize that, and I'll start by configuring the routers now according to what the lab manual says. So other than the clock rates, which will be missing, everything else should be able to be configured. So I'll just run through this now. So we're going to start by to prevent the router trying to translate incorrectly entered commands. I'm just going to enter the command IP domain lookup. Okay, I'll do that on all of these. That's the Windows 7 machine just starting up. So we'll go back to, what I'll do is I'll move them like that so I can flip between them. So I'll go back to router 1. And we need to configure the IP addresses, so I'll do that now. my interfaces are slightly different as I'm using GNS3. So just configure the IP addresses as your topology is. Okay. So interface serial 20 is the interface of route 1 connected to route 2. IP address is 10.1.1.1 255.255.255.252/30. Do no shutdown. Interface Ethernet 00. IP address is 192.168.1.1/24. And there we go. I'm going to apply no shutdown. So that's that done. Get out there. We'll move on to router 2 and apply the same configurations according to the lab. So we'll do interface serial 20 connected to route 1. IP address 10.1.1.2 255.255.255.252. Yeah, that's fine. Shutdown. Okay. Interface serial 2.1 connected to route 3. IP address is 10.1.2. Oops. 10.1.2. No. 10.2.2.2. Shutdown. We'll move on to router 3. Interface serial 2.1. IP address is 10.2.2.1. Shutdown. Interface Ethernet 00. IP address is 192.168.3.3/24. Shutdown. Exit. We'll just do a quick ping to see if we can ping. Yeah, we can. So we can get to router 2 from router 3. So that's good. And what we'll do is we'll just go across to the PCs and we'll log in and enter the IP addresses for these as well. So Lab 2 Windows 7 is acting as the PCC. So Lab 2 is PCC and the normal Lab 1 is PCA. So we'll start with Lab 1. Configure that IP address if it needs doing. And it doesn't look like it does because it might have been already configured from a previous lab. 1.3, so that's correct. 1.1, yep, so that actually doesn't need configuring. So we'll just verify that we can ping the default gateway, which is route 1. Yes, we can, so that's good. I'll just do the IP address for PCC, which is this one. I don't believe this one is set. Oh, it actually is 3.3. Okay, so we'll try ping the gateway. 3.1. Okay, so that's not working. We'll just verify these. Let's have a look. Let's scroll up 3.3. Oops, yeah, my mistake. I've done the wrong IP address or router 3's Ethernet 00 interface, and it's telling me there. So, interface Ethernet 00, no IP address 192.168.3.1. Okay. And we'll just try that again now. And there we go, that's fine. So we can see that that's working now. Yeah, but we can also get to the PC as well. So that's that sorted out. So what we'll do now is, before I move on, I'm going to configure this interface for the internet connectivity on router 2. IP address, DHCP. Now that should acquire an IP address automatically. We shall see. Okay, so that's acquired a DHCP address, and we should now do show IP routes static. We should actually have a default route. Yes, we do. So I'll do the domain lookup after. Do ping. Okay. We'll just see if that works. Yep, it does. So that's, we now have internet connectivity. So I'm just going to do the IP domain lookup instead of turning it off. And there we go. Now it works. So that's great. Okay. That should fail. Yep, that's fine, because we haven't set up any routes yet, which is what we're going to move on to now that everything is configured. So we're going to move on to, as the LAN manual says, configuring OSPF on the routers. So we'll start with router 1. So we'll do router OSPF. Oops. There we go. And we need to add the connected networks. So we've got 192.168.1.0. Wildcard mask is /24, and area is 0. And we're going to add another network, which is the 10.1.1.0. Wildcard mask is 0003, area 0. So there are 2 areas added, and we're going to make Ethernet 00 passive interface. It does need to receive the updates, so that's that done. Okay, so now we'll do the same for router 2 and then router 3. So 10.1.1.0, area 0, and we've got an adjacency there already, which is brilliant. And 10.2.2.0 0003, area 0. So that's for the router 3's network. So that's cool. Now we'll do router 3. Same again. And we add, so we've got an adjacency there, which is good. Then we add the 3.0 network, 255, area 0, and that's done. So we should be able to, let's do p google.com from router 1, oops, IP domain, lookup, paro, and we shall see. Okay, let's see if that works. And it's not working, and I think I know why. So let's go to route 2. By the way, this what I'm doing to actually get out to the internet is not part of the lab. This is an additional extra. So by all means, if you're doing it using JNS3 with the same topology and you want to follow along, then you can do. So I'm just going to do access list 1 permit any. And I'm going to do an IPNet inside, IPNet, yeah, inside source list 1. And the global interface is Ethernet 00. And we're going to overload it, which is port address translation. And we're going to do interface Ethernet 00, IPNet out, and we'll do interface serial 2.0, IPNet in, interface serial 2.1, IPNet in as well inside. We'll go back to route 1 and we'll see if we can get some traffic actually traversing out. Okay, that doesn't seem to be do short IP route. Okay, so you can see. Okay, so what we're going to do is we'll try redistribute the static route. So we'll do router OSPF 1. In fact, did I make I need to do passive interface on that as well for router 3 internal network. There we go. And where was that? So router 2 redistribute static so let's see now, because we don't have a gateway of last resort. Okay, let me do a the adjacencies form again. Okay, so let's do a default information originate. Okay. And there you go, you can see that we've got a default route now, which is on router 1, sorry, for from router 2, And now that we've redistributed that static route, so we'll see if we can actually get out now to the internet. And yes, we can. So we can see do ping google.com. Let's see if that resolves that. Might not, but we know we can. Yeah, we know we can still get out to the internet, so that's fine. Okay, so we should now have internet access, so we can take a look on these PCs as well. Ping Google's domain. So yeah, we have got internet access, which is good. Google.com. If that comes back. And we can also test that by connecting to the internet and having a look at the translations on router 2. Translations. So you can see we've got translations there as well, which is good. Let's just say go to Sky News. Give that a second. Oh, that doesn't look like the DNS, in fact, on this computer. Let's change the IP domain. Okay, well, what we can do, let's change this. Okay, preferred DNS. We'll do the DNS as Google itself. Okay. And that's better. So now that we've changed the DNS settings on that, we can see now that that's fine. And we have internet connectivity. There we go. So close that. We'll go back to our topology now and carry on with the lab. So we've configured OSPF on all routers. We have set the passive interfaces, and I've done additional steps to configure devices so that they can access the internet. So we are actually following the lab on step 4, and that is verifying OSPF neighbours and routing information. So we'll do that now by show IP OSPF neighbour. So we can see our, just widen that a little bit more. So you can see our neighbour. The interface is serial 2-0, which is this one. The IP address is 10.1.1.2, which again is this interface. And we can see that the state is full. Okay. The neighbour ID has also been set, which is the highest IP address. So what we'll do now we've done that, we'll do a show IP route. So you can see our routes in there. We've set up the all it one asked of in this lab, or at least yet we've set up the or redistributed the default route for router 2. Okay, so we can see that router 1 can now see that default route, and we'll just verify that with router 3. Yep, so you can see here, we can see that default route as well via 10.2.2.2, which is good. So step 5 is asking us to configure PC host IP settings. Now we've already done that. We've verified connectivity as well. So we don't really need to do that. However, for the sake of this lab, we will go to step 6 and verify connectivity between PC A and PC C. So we're going to do a few ping tests. So the first one is pinging from router 1, which is what we're on now, to router 3's IP address. So we'll do that. So we'll ping 10.2.2.1. Is that successful? We'll also ping 192.168.3.3. So we can actually get to PCC from router 1. Now we'll ping from PCA to PCC. 192.168.3.3. And there you go. You can see that that's successful as well. So we know that we've got connectivity across the whole topology, which is good. So we'll move on now to control administrative access for routers, which is part 2. So we're going to start with step 1, which is configuring a minimum password length for all the router passwords. So to do that, we enter the following, which is security passwords min length, and for this lab they want the minimum length to be 10. So we'll do that, and we'll just do that for the other 2 routers as well. Last but not least, a router 3. Okay, so that's done. So step 2 is asking us to configure the enable secret encrypted password on both routers. Use the type9 script hashing algorithm. Okay, so we'll do that starting with router 1, and we'll do enable algorithm type, and it's a script algorithm, and the secret followed by our super secret password, which is Cisco 12345. We'll do that for all 3 routers. So we'll do enable algorithm type script secret Cisco 12345. Last but not least, router 3. Oops, enable algorithm type script secret Cisco 12345. Okay. So now that we've done that, we shall move on to step 3, which is configuring basic console, auxiliary port, and virtual access lines. Okay, so we'll start with the console line, and we're going to do password Cisco con. Oops, and you see there it won't actually let us do that, so let's have a look what it's asking us to do. Yep, so it's just basically getting us to enter that password, and it will not let it work because we've configured the minimum length passwords to be 10. So I believe, yep. So we're actually going to configure, now that we've found that out, the password of Cisco Compass. Okay, so we'll do the same again. So password Cisco Con and add pass. Exec timeout is going to be 5 minutes, 5 space 0, and login and login synchronous. Okay, we'll do the same for router 2 and router 3. Okay, so we'll go back to router 1. We're going to go to the aux. So, password, Cisco, aux, pass. Exec timeout is the same again, 5 minutes. And log in. Then we'll go to router 2 and do the same. And router 3. Okay, so that's that done. So we'll move on now to the next step, and it's asking us to telnet from router 2 to router 1. So we'll go to router 2. And what we'll do is we'll telnet to 10.1.1.1. And it's saying that the connection's been refused. Now, there's if you are following the lab manual, there's a few questions on why the login has been refused. Okay, I'm not going to answer those for you. I'll let you figure those ones out. So moving on with the lab, we're going to now configure the VTY lines. Line VTY04. Password is Cisco VTY pass. Exec timeout. 5 minutes again. Transport input telnet, which you wouldn't do on a production network. And then login. So you're probably actually going to find out the answer now as to why it didn't work last time. So we're going to telnet from router 2 again to router 1. And it's asking us for a password now. So you've probably worked out the answers to why that didn't work in the first place. So we'll do Cisco VTY pass. And we're in. Okay, so it's asking us to enter privileged exec mode and issue so run. Can you read the enable password? So Cisco compass. Oops. Let's have a look. So it's Cisco 1, 2, 3, 4, 5. There we go. Now we need to issue a show run. As you can see there, we can't see the password. Okay. You can tell it's a type 9 because of the 9 depicted here. You've got your password string here, which just looks like a load of rubbish. Okay. So moving on, it's asking us now to encrypt clear text passwords. So to do that, we do go back to global configuration, and we do service space password encryption, and we'll do that for all routers. Service password encryption. Okay, so that's that done. Now it's asking us to do a show run and see if we can see the passwords for the VTY LANs, the auxiliary line, and the console. Now that we've done the password service encryption, they should all be gobbledygook as well, which they are here. So we can see here type 7 passwords, which is not really secure, to be honest with you, but there we have it. So task 2, we're going to configure a login warning banner on routers 1 and 3. So we'll do the following: banner, message of the day, and we're going to do unauthorized access is prohibited. Exit, and route 3 as well. Cool. So now that we've done that, moving on, we're going to do a show run, and it's asking us what the dollar converts to in the output. There we go, so you can see what the dollar signs have actually converted to. So there's your answer there. So moving on to task 3, we're going to configure enhanced user name password security on router 1 and router 3. So we're going to start with router 1. Create a username called user01. Algorithm type is script. Secret is user01 pass. Okay. Exit global configuration mode and save your commands. Okay. Copy and start. Display the running configuration, and let's have a look which hashing method is used for the password. So we can see there that we've got a type 9, which is for user 1, which is a script. So now we need to test a new account by logging into the console. Okay. So to do that, we need to enable login local. And we'll do login local and exit user 01 user 01 pass. Okay. Cisco 1 2 3 4 5, and we're in. So, a few questions in the lab. Moving on to step 4. We're now going to test the new account by logging in from a telnet session. From PC A, establish a telnet session with router 1. Telnet is disabled by default in Windows 7, so we need to enable that if it's not already enabled. So we'll try and telnet in. So for now, we'll exit out there. Telnet to 192.168.1.1. Yep, so it's not enabled, so we'll go to services, features. Just give this a second to load. Taking its time. Let's just try and close it and open it again. There we go. So telnet client, we need to enable that. Okay, give that a second, then we'll try and telnet to router 1. The VM does take its time sometimes, so we'll tell that now, and there we go. It's only asking us for a password. Now there's a question in the lab about this, asking you if you were asked for just a password. So we'll do the password. So let's go 1 2 3 4 5. Okay. So we need to just go to user 01. On the VTY line, the reason that's not working is because this is a question answered. There is no login local to use the local user account, which is obviously the user one that we've created. So we'll set that now. VTY04 login local. Exit. Now I'll try again. There we go. User 01. user 01 pass, enable Cisco 12345, and there you go, we can see that we're in now. So that works straight away as soon as we do that. So Yep. So if I do security, set the aux port to use a locally defined login account. So we'll do that as well. Login local, if I can spell it right. There we go. So that's that done. So we're going to move on now to task 4, which is configuring the SSH server on router 1 and router 3. So we'll start by doing it on router 1. So we'll do IP domain name, and we're going to use CCNA Security.com. We'll do it on router 3 just to save time. Oopsie. So we'll do domain. There we go. So moving on, we're gonna configure the, well, it's asking us to create a username called admin with full privileges of 15 and using the algorithm type script. So we'll do that now. Privilege 15, algorithm type script, secret, Cisco 12345. Do the same on route 3. There we go, flip back to route 1. So now we're going to configure the VTY lines. So we're going to specify a privilege level of 50 so that users with the highest privilege level 15 will default to the privileged exec mode when accessing the VTY lines. Other users will default to the use exec mode. Okay. So we'll do line VTY 04. Does it support privilege level? Yes, it does. $15. Login local. We're going to only allow for SSH only with a transport input SSH. We'll exit. We'll do the same on router 3. So we'll do privilege level 15. Login local. Transport input SSH. Okay. So now we're going to generate the crypto keys. So we'll do crypto key generate RSA, and for the purpose of this lab we are using a key size of 1024. Cool, so that's that done. We'll do the same for root 3. Crypto key generate RSA. Okay, that's that done. So we'll enable, if we do show IP SSH, you can see that we're using version 1.99. So we'll do conf t IP SSH version 2. We'll do the same again. And now you can see that we're using 2.0. So we need to do the same on root 3, because you'll see there that we're using SSH 1.99. We'll do IP SSH version 2. Then we'll do show IP SSH, and you can see that we're using 2.0 now, which is what we need to be on. So we have done that now. We're going to now move on to step 7 in the lab manual, which is configuring SSH timeouts and authentication perimeters. So we're going to configure an SSH timeout of 90. Conf T. So we'll do IP SSH timeout. You can see there you've got the timeout in seconds. So we're doing 90 seconds. We're going to do IP SSH authentication retries. So you got 2 attempts to retry, then it'll set you back to the start again. So we're going to set that to 2. We'll do the same with root 3. So IP SSH timeout 90 seconds. IP SSH off retries 2. It's asking us to do copy and start. So now we are going to move on past all the questions and install an SSH client on PCA and PCC. So something like PutA or TerraTerm will do. So yeah, let's just have a look on our devices and see if we have these on PCA and PCC. So we have PutA there on PCA. So we'll go to PCC, and it doesn't look like we do. However, we can get that hopefully by connecting to the internet. We'll have to change the DNS settings just like we did on PCA. Let's set it to Google's public DNS. And that should be better now. Let's send a quick refresh. And there we go, we can see that that's working now. So we'll get PutA. PutA is free to download, really quick. There we go, so we have PutA now, so I'll pin that to the taskbar as well. Okay, so that's that done. So we're verified now that we've got them both installed on both clients. So we're going to verify SSH connectivity to root 1 from PCA. So we'll go back to PCA, which is this one. We'll open PutA. And we'll connect via SSH port 22 to 192.168.1.1, and there you can see that it's working because it's generating as the fingerprint. There we go. So we're going to log in with the admin account and the Cisco 12345. You can see now that we're in route 1. So at the privileged exec prompt, enter the show users command. So you can see that we have the console 1 user 01 who's idle, and we also have us, which has just popped up as admin, and we also have the VTY 0 user 1 as well. So that will be this one. So if I exit out of this one, connections are lost, and try again. There we go. So we can see there that we're only logged in on the actual console itself on router 1, and as admin now, which is on the VTY line. The user 01 that I've just logged out of the VTY line was this one, so it's not connected anymore. So in fact, you can see that. In fact, I'll just make this one a little bit bigger as well, so that we can see. There we go. Okay, there we go. So that should be better. So yeah, as I was saying, the old user who was on the VTY line as well is being logged out on here from the command prompt, and we are only using admin now on the putty SSH session, and the console user 01 is physically or would be physically connected here on router 1. So now that we've done that, we're going to close the putty SSH session window, so we'll do that. Close. And it's asking us to try open a telnet session to your router from PCNA, and it's probably not going to work because we've done the transport input SSH only. So we can try it, telnet 23, and we'll do 192.168.1.1. There you go, it's not working, as you can see. So that's your answer there. Open up the SSH session. Open and put the SSH session to the router from PCA. Enter user 01 username and password. Okay, let's have a look at this. We'll do SSH again, 192.168.1.1, and we're going to use user 01 pass. And as you can see there, because we are not privileged level 15, we wasn't taken to the privileged exec mode. So if we open another putty session to the same place, 192.168.1.1, let's just make this bigger again. Put this one there, and with this one we'll log in as admin. Cisco 12345. And as you can see there now that both levels are different. So because we've set admin to have a privilege level of 15, we can see that it's taken us to the privileged exec mode. Whereas because user 01 has not got a privilege level of 15, it's not taken us to privileged exec mode. Okay. So I'll just close those for now. And moving on, we're now going to configure an SCP server on router 1. Now that SSH is configured on the router, we're going to configure router 1 as a secure copy SCP server. So the first step is to use AAA authentication and authorization defaults on router 1. So we'll do that now. So we can do that. Log back in as admin, Cisco 12345, if that was right. I don't think it was. Admin. There we go. We do AAA new model. And we're going to do AAA authentication. Login default local. So the default login is local. And we're going to do the same for authorization. Authorization. Exec mode. Default is local. So we're going to enable the SCP server on route 1. So to do that we do IP SCP server enable. So we're going to copy and start that. And moving on. In fact, what we need to do, we actually need to specify a name for this save. Copy, run, running configuration, and we're going to call this one router 1 config. Okay, that's no directory. I think it's because of the actual image. So let me just do show flash. Ooh. Yeah, I think it might have something to do with this image. Let's do a show. Yeah, there's no show flash on there. Yeah, I think that's actually something to do with the image itself that I'm using, but not to worry. We have saved the configuration to the running config, so we'll see if we can actually use that later on. So we'll move on to step 3, which is use the SCP command on router 3 to pull the configuration file from router 1. So let's have a look, see if we can actually do that. Cisco Compass. So we're going to do copy SCP flash let's see if this works. Copy SCP. So you don't have any flash there. Let's try startup config. So we're going to do the host as 10.1.1.1, which is router 1's interface. The source username is admin. Source file name, I wonder if it can leave that as blank. Yep, and destination, we'll just enter on that. Password Cisco 12345. No such file directory, so we can try again. Not that one. Yep. Let's see if we can. Having problems here because this virtual image doesn't have flash. I'm just seeing if we can actually do it another way. Let me try do yeah, I think we're gonna have to move on without actually doing this one because of the flash. So we're not going to be able to use the SCP to transfer the running configuration or the save configuration from router 1 to router 3. The reason is because of the images that I am using. However, for those that are using physical equipment and are able to do so, please do so. If you want to know the commands, if you don't have the lab manual to actually do this, just drop me a comment and I'll be able to provide you with those commands. But we still have quite a bit to do left in this lab, so we'll move on and we'll get started with this lab. So the next stage, we're going to configure administrative roles, and we're going to configure different views or parser views, if you like. So our first task is to enable root view on router 1 and router 3. So we'll just start with router 1 first. So we'll do a triple A new model. And we'll do enable view. Okay. Enable view. There we go. Cisco 2345. So we're going to create a parser view for admin 1. global configuration. Parser view admin 1. Now you can see that we're actually in the view. So we're going to do secret is admin 1 pass. And we'll do commands. And you can see we've got a long list of commands we can actually run, or allow admin 1 to run. So we're going to add all configs, so all the show configurations, all the debug configurations. So we'll do that now. So commands exec include all show commands. And we're going to include all global configuration commands. And we're going to include all debug commands. So we can verify the admin1 view by showing parser view. So we'll exit out of this. So our current view is root. So we need to enable view admin1. Password was admin1 path. So we'll do a show parser view as well, and now we can see that we're in admin1, so we can see the switch there. So if we do show question mark, you can see we've got all the normal commands you would at a privilege level 15, which is what we want. Now we're going to create user 2 or admin 2 view. So enable view Cisco 1 2 3 4 5 T, and we're going to do parser view admin 2 secret admin 2 pass. And we're going to do only include all show commands. Yes, this one's exec include all show commands. And that's it for user 2, or admin 2 should I say. So we'll do enable view admin 2 pass show parser view. So we can see we're admin 2, so we'll do show. We've got all the show commands there. Okay, so let's do T. So you can see there we can't actually enter global configuration mode because we've only enabled all show commands. So now we're going to create a tech view. So we'll do enable pass, we'll do enable root, enable view, let's go 1 2 3 4 5, parser view called tech. Secret is tech pass WD, and we're gonna do commands exec include show version. So you can see we're getting quite granular now with the commands. We'll up arrow that, include show interfaces, up arrow show IP interface brief, and we'll do include show parser view, show. So we're getting granular with the commands now, and we'll end that and we'll enable view tech pass wd show parser view. So we're in tech now. Let's do show, and as you can see we can only show certain things here. Oops, and I can see I've done a command wrong here. So what we'll do is we'll do enable view. Let's go 1, 2, 3, 4, 5. Parser view tech. Parser view tech. And we'll do, there we go, show IP interface brief, exit, parser view tech, enable view tech, sorry, tech pass WD, show parser. Yep, so we'll do show question mark, show interfaces brief, we'll do show IP interface. We should be able to do brief if this is a command. Yeah, it doesn't look like it's on there with this version, but yeah, show IP interface. So that's the tech one done. And as you can see with the show and question mark, we only have a few commands we can actually use, so you can get very granular with parser views in creating them. Okay. So let's just try show IP root. We can't issue that command because we didn't specify that. So we're going to return now to the root view. So we're back at root now. If we do show, we have everything again, which is good. So we're going to save the configuration now and move on to part 4. So part 4 is configure iOS resilience and management reporting. So in part 4, the lab that we're actually following, we're going to configure the Cisco iOS image and configuration files, configure SNMP version 3 security using access control lists. We're going to use NTP, configure a router as a synchronized time source for other devices. We're going to configure syslog support on a router, install a syslog server on the PC and enable it. We're then going to configure the login trap level on a router and make changes to the router and monitor syslog results on the PC. So we've got a lot coming up. So I'm going to jump straight in with task 1, which is securing the Cisco iOS image and configuration files on router 1 and router 3. So to kick straight off, as we've already identified on this particular lab of mine, I cannot issue the show flash. So I may have a few. Let's have a look. Let's see if we can actually secure the boot image. So the secure the boot image command enables the Cisco iOS image resilience, which hides the files from the command show. Well, which hides the files from the show flash and the rest of the commands. The file cannot be viewed, copied, modified, or removed using exec mode commands. It can be viewed in a run mode when turned on for the first time. So let's have a look, see if we can do this. So lower configuration, we'll do secure boot image. So we can actually remove the command. We can actually add the command, but as you can see there, it's spitting out a syslog message on mine, say the iOS resilience 5 image not found, running image not found on removable disk. Okay, so again, that's something to do with my particular image that I'm using, but we shall carry on and we'll run the next command, which is secure boot config. Okay, and this takes a snapshot of the router's running configuration and archives it. So as you can see, it has, well, it's saying it's actually successfully archived it, which is quite good. So that's good to know. We're then lastly going to show secure boot set. So and that's actually just showing the configuration file. Which is good. So it's still telling me that the image resilience is not active, and I believe that's because of this command that I cannot run, but it's not a problem. We shall just move on. So to disable the image resilience, we just run the command no secure boot image. So as you see, it's not active anyway on my particular device, as it won't allow me to enable that. So we'll do the same with the config file. Secure sorry about that. So as you can see there, it's removed the file as well and disabled it, which is good. So I won't go ahead and save the config because we've not really made any changes there. But in task 2, we're going to configure SNMP version 3 security using an access control list. Okay, so we'll jump straight in with this now and get through this lab. So we'll start with route 1, IP access list. Standard, and we're going to call this permit SNMP. So we're only going to allow packets, only packets on route 1's LAN. So we're going to commit 192.168.1.0 wildcard mask 000255, and that's it. We'll exit out of that. And we're going to configure the SNMP view. So SNMP server view SNMP read only, ISO included. So this means it's going to include the ISO MIB family. So we're going to move on now. SNMP server group. We're going to call the group SNMP G1. Using version 3. Privilege is going to be read SNMP read only. Access, and then we're going to add our access list. Permit SNMP. Okay. So we're going to configure the SNMP user. So configuring SNMP admin user and associate the user to the SNMP group 1 group you configured is step 3. So we'll do that now. So we'll do SNMP server again. User SNMP admin SNMP group 1 version 3. Authentication is SHA off pass privilege AS 128. Yep, encrypt. Okay, that should work. Please wait. So we'll just end that. We'll do show SNMP group. SNMP read only. Status active access list permit SNMP 3. Security model version 3. Yep, group name SNMP G1. Cool. So that's fine. Let's do show SNMP user. So we can see our username that we created there is SNMP-admin. And it's using AS128 and it's assigned to SNMP group 1 and it's shown as active, which is good. And it's using the authentication protocol SHA. So moving on to task 3, we're going to configure synchronized time source using NTP. Route 2 will be the master NTP clock source for routers 1 and router 2. Route 2 could also be the master clock source for the switches S1 and S3, but it's not necessary in this lab, especially my lab, as these switches I'm using are just unmanaged switches. So we'll just do a show clock. And that clock's actually right. So we won't actually set the clock. However, we will follow the instructions and configure the NTP settings. So we're going to start by configuring the NTP authentication by defining the authentication key number hashing type, as well as the password that will be used for the authentication. So we'll do that now. So we'll do that on route 2. Let's a second, and let's have a look at this. So we'll go ahead and we'll enter the password. There we go. So NTP. In fact, we'll do a show clock first. The clock's the same. So we'll do NTP authentication key, and we'll do key 1, as you can see you can have any key number within that range. MD5, and the password is NTP password, and it is case sensitive. Enter. So we need to configure trusted key that will be used for authentication on route 2. So we'll do NTP trusted key 1, and NTP authenticate. Oops. And NTP master 3. So moving on back to route 1 now. We're going to do NTP authentication key 1, MD5. The password is the same, so NTP password case sensitive. NTP trusted key 1 and NTP authenticate. And we'll do that as well for route 3. So NTP authenticate, MD5, NTP password, and we'll do NTP trusted key 1, NTP authenticate, and we need to do the NTP server, which is the IP address of router 2, 1.1.2, and NTP update calendar. We'll do the same for route 3. NTP server 10.2.2.2 NTP update calendar. So we can do a show IP show NTP associations. So we can see that our address of the server is 10.1.1.2. Do the same for route 3. So as well, there you can see. So now, according to the lab guide, we're going to use the debug NTP all command to see NTP activity on route 1 as it synchronizes with router 2. Okay, so we'll do that. And what I'll do, just so we can see the synchronization, is I will do 9TP server again. And there we go. We can see that the messages are coming through now. NTP message sent to 10.1.12. Yeah, message received. Next action is 1. Yep. So you can see the communication happening there. So I'll just do you all. Let's turn that off, and we'll do show clock. So we can see our clock is currently at the right time. So we're going to move on and configure syslog support on router 1 and PCA. So we're going to install a syslog server onto the PC. So let's just have a look at this. So let me see if I have a syslog server already. No problem, we can get one online. So we could get TFTPD32. We'll just download this, and I'll also get it for the other computer. I'll just install this now. Yeah, we can start it. There we go. We'll allow access. That's that done. We'll come off that, and we'll just switch back to PCC and ensure that this is started. So again, yep. Cool. So there we go. We now have them installed. So now that we've got them installed, we're going to configure route 1 to log messages to the syslog server using the CLI. So we know we already have connectivity, so we just need to enter a few commands. So the first one being is service timestamps log date and time seconds. Okay, and we're going to do login host 192.168.1.3, which is the PCA. So that's login setup on that now. Okay. So we're going to configure login trap levels now. So let's have a look. So we're going to login traps warning. So in fact, before I do that, I'll question mark it so you can see the different severity levels here. So we're looking for warning, which is severity 4. Okay. So you can see there that we have the login set up now, and these are all the logs. So let's see if we can get these. Let's explore this now. So it's that one. Yeah, so you can see logs there, syslog. Let's just open this up a little bit. Okay, it can go down here. And IP address, so bring that back up a little bit. There we go. So let's come out of that there. In fact, we'll do no login chats warning. You can actually log anything, well, everything. So we can log 7 debugging. And as you can see there now, everything's coming up there. So that message there has just been sent to our syslog server, as you can see. So if I do interface serial 20 shutdown, you can see as well there that the adjacency changes there, and the interface down is popped up as well. So I could do a no shutdown and we should get new messages again. You can see all the OSPF adjacencies forming again, so that's syslog working successfully. Okay. So that's in essence. I won't do the same for PCC, but in essence that is the sort of activity that will happen. And you can see which IP address it's coming from, and date and time as well. So in fact, if we do a little experiment and we SSH to root 1 and we log in as user 01, let's say, and if we do a interface 02.0 and we shut that down, we'll see if the IP address is different. Nope, it's not different because it's logging from the actual device itself. So there you go. If you send that command from effectively this workstation, it's still going to log it from the actual device itself. So that's just something interesting to note. So we'll do a no shutdown, exit out of that. There we go. So like I said, I won't do the same with PCC. You get the process, that's how it works. We'll move on now to part 5, which is securing the control plane. So we're going to do this by controlling OSPF. Okay, so we'll start with root 1, and I'll leave the login up there so we can actually see it as we go along as well. So we'll do keychain, netcard, again case sensitive, key 1, and we'll do key string, CCNA S key string. We're going to configure our encryption algorithm. So we'll do cryptographic dash algorithm HMAC SHA-256 for the purpose of this lab. We'll now go on to do the OSPF authentication, so IP interface to enter the serial 20 interface. IP OSPF authentication. Keychain is the keychain that we've just created, so NetAcad case sensitive. The adjacencies should go down now till we configure it on router 2, router 3 once the dead timers, once it times out. Is it 2-0? Yeah, it was 2-0. Okay, so we'll leave that a minute. We'll show IP OSPF. Yeah, so you can see there the dead time has expired now. So the adjacency has gone down, and that's because now that we've configured authentication on router 1, router 2 has no authentication, so in effect it's not valid until we configure router 2. So we'll jump on to router 3 and we'll do this as well, just for a bit of extra practice. So we'll follow the same method. So we'll create a keychain, call that NetAcad key1. Then we'll do keystring CCNA case sensitive keystring. Then we'll set the cryptographic algorithm of HMAC SHA-256. Then we'll go into interface serial 21 on this router, and we'll do IP OSPF authentication keychain is NetAcad case sensitive, and that adjacency should then fall quite soon. So if we do a do show IP OSPF neighbor, so you can see the dead timer's counting down there. Once that dead timer gets to 0, we should see that the adjacency goes down. So 9, 7, 6, 5, 4, 3, 2, 1. So we should get an adjacency in a minute. That's there we go. So it's gone down. That's in effect how the dead timer works. So now we need to go to router 2 and configure that so the adjacencies come back up. So yep, we need to, so let's have a look. So we'll go on interface serial 20, and we'll do IP OSPF authentication keychain NetAcad. And as you can see there, we've got no valid keychain because we've not actually created the keychain. So we need to do the same. So what we'll do is we'll do that now. So we'll do keychain NetAcad key1 keystring CCNA key string, cryptographic algorithm type, mark SHA-256, exit interface serial 10. So you can see there that that's actually come back up now. So let's do show IPS OSPF neighbors. So we can see that we've got a neighbor there, but we still don't have a neighbor for serial 2.1. So we need to configure that now. Interface serial 2-1. We do IP OSPF authentication, keychain, metacard. And that JSON should come back up now. And there you have it. So we do exit out of that, and we'll do a show. There we go. So now we can see both neighbors, which is good. So now we've got authentication and we've secured the control plane. So if we do a show IP OSPF interface serial 2.0, so here, if we investigate this further, we've got a lot of information. We can see that cryptographic authentication is enabled. We can see the algorithm type that we're using, and we can see the key chain that we're using as well. So we know that that's all perfectly working and fine now. So that completes that. So we're going to now move on to part 6, which is configuring automated security features. So we're going to use the auto secure to secure router 3 and review router security configurations with the command line. So we'll move on to router 3 for now. We'll leave router 1 alone. And what we're going to do is exit out of there. We're going to type auto secure. Okay. So it says auto secure enhances the security of the router. It will not make it absolutely resistant to all security attacks. Auto secure will modify the configuration of your device. All configuration changes will be shown. For detailed explanation on the configuration changes in enhanced security and possible side effects, please refer to cisco.com. Okay, so going back to the lab, we are going to answer these questions. So the router is connected to the internet. Enter the number of interfaces facing the internet. Okay, so we're going to click 1, which is the default. So we'll enter that. Enter the interface name that is facing the internet. So the interface name that is facing the internet is wherever it is. 192. So it should be. This is router 3, so it's 2.1. Serial 2-1. There we go. Security banner. So here's a sample security banner. So it's asking us to enter a security banner now. So we'll do that. put the banner between the K and the K where the K is any character. So what we'll do is unauthorized access is prohibited. Enter the new enable password. So we'll do, following the lab, Cisco 67890. Cisco 67890. So blocking period when login attack detected. So this is going to be 60 seconds. Maximum login failures for devices, we'll keep that at 2. Maximum time period for crossing the failed login attempts, we'll do 30 as the lab says. And we're going to configure the SSH server, so the default's already selected yes. So we're going to, it's asking us now if we want to configure the content-based access control firewall features. And for this lab, we're selecting no. Enable TCP intercept features. We will do yes. I don't think that's actually covered in the lab. Let me just have a look. Yeah, it's not, but we'll leave that on. So this is everything now. This is just giving us a summary of what we've done. Apply the configuration. We're gonna select yes, so we'll press enter. There we go. So configuration's been modified now. So moving on to step 2, it's going to ask us to establish an SSH connection from PCC to router 3. So we'll see if we could do that. So we'll go to PCC, put it. That'll be 192.168.3. Oops. Do that again. Fat fingers. 192.168.3.1. Okay. So we're going to log in now, and we'll log in as user 01. I think we created. Let's try user 01. No, let me just go back and see what user we actually created. So we'll go to root 3. Let's just ask us for the password. In fact, no, it's not. That's my fault. So because we haven't really used root 3, we've got the user. It's not user, okay. So let me try open that again. So just keep disconnecting me. So let me just try. In fact, what we'll do is we'll just flip back to so there's a keychain. Can't remember the user that we. Aha, I had it then. I thought I had it. So login enable, username admin. So yeah. So it was admin. So it's 2 attempts and it's closed the session now because I couldn't log in with the password. However, we'll have a look at what the password is now. However, that's pretty much the end of the lab, and all it's asking us to do now is to log in with SSH to have a look at the banner that we created, which will be shown when we log in. So that's pretty much it. For those that are actually following the lab manual, there is a few questions towards the end of this lab which I'm sure you'll be able to answer. I hope that's kind of covered everything in the lab and a little bit more, especially, you know, routing out to the physical internet for anybody actually using GNS3 as well. For those that have any questions moving forward, you know, drop me a comment on this video and I'll happily get back to you. But that's it for now. Thank you for watching.